Hi and welcome to Unit 2, Topic 3, Video 23. This is our final video for this series on Topic 3, matrices. We're going to look at the area and the determinant of shapes and their transformational matrix. There's a nice little connection here. Now what I'm not going to do is go into the proof behind this. You're welcome to explore this a bit further, but you don't really need to know the proof. And so I'm just going to make this video pretty quick, just showing you a couple of examples of what this little rule is. So firstly, it can be shown that the area of an image is equal to the determinant of the transformation matrix times by the area of the original. That's all it is. It's that simple. And example 1 says, show that this is true for the transformation that takes xy to 3x plus 2y, comma 2x plus 5y. So what I'm going to do is I'm going to start by just looking at what this a value here is. If a times xy goes to 3x plus 2y and 2x plus 5y, well, then this means that a must be equal to 3, 2, 2, 5. And we've seen this transformation matrix before. It does stuff. Doesn't really matter what stuff it does. It's got some shears going both ways. It's got some dilations, whatever. But it also transforms the shape. Now, the determinant of a is important here. The determinant of a is 3 times 5 minus 2 times 2, which is 11. So what I'm claiming here is that the area of the image is going to be 11 times the area of the original. Now this is by no means a proof, but it does give us an example which is unlikely to be coincidentally true. So we should be able to convince ourselves a little bit, if not give ourselves the reason to go looking for a proof now. So let's have a look. I've already drawn this shape. Down here, we'll do our multiplication. So this is a unit square. So a times by x is equal to 3225 times by the unit square 00011011, and this of course is equal to 00 again, 2 5 3 2 and then 5 7, and they're the coordinates I put on there. So you can see the unit square is a black one, and the outside image is the image shape, so the transformed shape. And you can see that sort of shear in both directions and the enlargement, the dilation. Okay, so firstly, the area of x equals 1. Unit square has an area of 1. We need to find the area of this purple shape though. So this area in here. Now, I'm going to do this really quickly. I don't want to muck about, but hopefully you can see that we can calculate this area just by looking at a few triangles. So if I split this up into one triangle, and then a trapezium, and then another trapezium, and then a triangle down here, hopefully you'll see that we can work out these areas. So area 1, well, it's got a height of 5, and it's got a length of 2. So this is 5, this is 2. 5 times 2 times half has an area of 5. I'm being quite quick about this, so I hope you'll forgive me for that. Area 2, well, this has got a base there of 2. It's got a height here of 5, height here of 2, as we've already seen. And so it's a trapezium. 2 plus 5 divided by 2 is the average width of the trapezium. So that's 3.5 times 2 is 7. So the area of this one is equal to 7. And then we've got this sort of pinky one here, 3. And the area of 3, well, it's got a height of 7 and a height here of 2 and a width of 2. 7 and 2 have an average of 4.5 times 2 is 9. So the area of this one is 9. And then we've got our last one, which is the area of shape 4. And that's got a width of 3 and a height of 2 as we've seen. So that's 6 divided by 2 and area is equal to 3. That means that our total area missing is equal to 24. Now, we have a large rectangle with lengths 7 and 5. So the area of the rectangle equals 5 times 7. And therefore the area of the purple shape is equal to 5 times 7 minus 1, 2, 3, and 4. So if I subtract 1, 2, 3, and 4, I get 35 minus 5, minus 7, minus 9, minus 3, which is 35 minus 24, which is 11, which is 11 times the area of the original. And there we have it, 11 times based on that rule. Let's have a look at a second example, and this is a lot more common. This rule seems to pop up occasionally, just rarely, but occasionally, where you can use it quite quickly, maybe a multiple choice or a simple familiar. The matrix M maps the triangle with coordinates that to a triangle 6 times as large. So it's important here that you're given coordinates, you're given the word maps, and you're given some notation for coordinates for matrices. It can be a bit confusing, but it doesn't need to be. So we know that if M has area X units squared, then M image has area 6x units squared, because it's 6 times as large. And therefore the determinant of M, so the matrix M, so I shouldn't use M, I should use X and X dash for the triangle, must equal 6. And the determinant of M is M squared minus 2 times 5 must equal 6, which means that M squared equals 6 plus 10, which is 16, and M must equal plus or minus 4. And it's not a length, so it's very reasonable for M to be negative 4 here. That works as well. And so there we have it. Our value of lowercase m is plus or minus 4, using the rule and our knowledge of determinants and how they affect areas. Okay, so that's our final video for matrices. Good luck with it, and remember, do some work and then ask some questions. It's the way forward. All the best.